Okay, in this module, you're going to learn that how UDP handles sending and receiving of UDP packets. Okay, so basically, it depends on these three modules. That is control block module, input module, and an output module. So there is something known as control block table. So what is control block table? First of all, let us look at this. So control block table has some entries like process ID, its port number associated with it, and it also has something known as queue number, queue number, and it has something known as state. In state, either the port can be free or in use. Okay, these are the two states present over here. So in control block model, you will be having this kind of table. So it is helpful in just keeping track of the port. Okay, whether it is free or in use. If any port is free, you can assign your user datagram to that port, which has been received from the receiver in that case. Okay, now control block module is going to is the module which handles the control block module. It manages is basically its task is to manage the control block module. Next is the input module and output module. So let me show you the diagram over here. Okay, this is the sender and this is the receiver. Suppose, okay, from sender some data is going to through the output module, and that data will be going through the input module. At this point, there is one control block present over here, control block table, which we discussed over here. So it consists of these entries. Okay, that is process ID, port number, and queue number, and the state of that port. Okay, and who is going to manage that? Control block module is going to manage that. Okay, suppose whenever a process is running, okay, operating system is going to assign the port number. In that case, in that case, control block module will be the one to make the entry of that process ID in the control block table. Okay, now let us look towards the input module. So what is input module? So suppose this sender has sent some data packet to this. Now this is the input module over here. Okay, how actually the code is. See here, this is very nice example over here. You can look at this thing. Okay, so first of all, it is going to receive the user datagram, right? In this case, there will be layers over here. Okay, so at network layer, it is going to remove the header, IP header, and all those stuff, and it is going to pass the UDP. It is going to pass the datagram, and that datagram would be received to the input module. Now, based on that UDP user datagram, in that you have destination port number, right? In your datagram, you have destination port number, and if that port number is found in your control block table, okay, control block table, if that is found, then it is going to if see here, if found is for that destination port number which was sent by the sender. The destination port number is going to lie over here, right, in some of this process. Now suppose it is present over here, then it will go in this loop, in this if. Okay, in this if. Now check if the queue is allocated. There is queue allocated for each port, right? And suppose for that port number the queue is not allocated, the code says to allocate a new queue for that. Just allocate a queue for that port number and start it. Okay, else if suppose queue is already present, then just enqueue the data. This is what the code says. Now suppose the destination port number which was sent by the sender is not present in the control block table itself. It is not there. It means that it means that it is uh, it is an wrong port number. Okay, that's why it is going to say as ICMP. It is going to send an ICMP packet saying that a port is unreachable. Okay, in that case, suppose the destination port number that was sent by sender is not present at this in this control block table. In that case, in that case ICMP error message would be sent. Okay, and the user datagram would be simply discarded. Now the next is the output module. In output module, see, simply sender is going to send some message, and that data would be create now based on that data you will be adding some header, that is the UDP header, which makes it as user datagram. Now you are going to just simply send the user datagram. Okay, this is the output module. Output module is simple. Okay, now let us look the code for control block module. So control block module is going to see, whenever a process is going to start, operating system is going to assign a port number. Okay, now it is the responsibility of control block module to add that tuple inside the control block table. Okay, therefore its input is process ID and port number. It's respect to port number, right? Now control block module will be the one to make the entries in the control block table. Okay, so it is just creating a new entry with the state in use. Okay, it is going to say the state as in use. Okay, and it is going to just enter the process ID and the port number. Okay, this is the simple code for control block module. Now based on this concepts, let us solve one example. This is okay, this is the screenshot of the example. Okay, now this is how the control block table looks. Okay, there is a state, there is process ID, and there is corresponding port number, and there is the queue number, as I discussed. Right, now the state can be either in use, the port number can be in use, or it can be free. Right, now here there are some cases which you need to see. Okay, now suppose there is an user datagram which is being arrived at this port number. Okay, now what changes is it, will it make some changes in this control block table? See, the arrived port number is destination is 52,012, right? Now when you check in the control block table, see, input module is going to check, right? Input module is going to check for that thing. Now input module is going to see that its queue is already present. See, 38 queue number is already present for this port number. Okay, therefore it is just going to send the data via this queue number, via this queue. Okay, therefore it is not going to make any changes in the table itself. Now in the next case, suppose there is an process which is asking an port number from the operating system. Now this is the port number which is assigned by the operating system to the process. Now process is going to send that port number and the process ID to the control block module. Now control block module is going to make changes in the control block table. Now see, for this port number, this is the process ID, right? Therefore in the beginning, if you see, there are two free spaces in your control block table. This is first free space and this is the second free space, right? This is the first and this is the second. Now as soon as it sees the first free space, the control block module, it will be making an entry here. What will be the entry here? It will be saying in use. What would be the process ID over here? Process ID would be this 4978 over here, 4978, and the port number would be 52,014. Okay, and queue number right now it uh, queue number right now it has not been assigned any queue, right? Now in the next part, suppose a user datagram has arrived at port 52,011. Okay, now what happens? See, first of all, it is going to see, your input module is going to check whether this port number is present. See here, at this point, it is going to input module is going to check whether this port number is present. yeah, this port number is present in our control block table. Yeah, therefore this is an valid port. Then it is going to check whether a queue number has been assigned. No, it does not contain any queue number, right? Therefore the input module is going to assign an queue number to it. That is for 43. It has assigned 43 to this port number. Okay, therefore this entry would be valid. This is how the table would look after this case. Now suppose this is the last case. Okay, now suppose I say send this to this port number. Suppose there was a packet reached at the input module saying the port number is 52, destination port number is 52,055. Now input module is going to look for the port numbers. Is this present? No, no, no. Therefore you are not able to find this port number over here. In that case you will be sending an ICMP error message. Okay, what is that error message? It says port unreachable. Port unreachable. Okay, this is the error message which is being given, and it is going to silently discard this your packet itself. Okay, thank you. Hi guys, so basically we have ended the chapter. So let me just summarize the whole chapter in short. Okay, so in this chapter you have studied about UDP, that is user data protocol. So first of all you just studied about the format of header. In the beginning we studied format of the header, and after that we just studied about the some of the UDP services. What kind of services? Like flow control, error control. We also studied something known as queuing, right? We studied queuing, we studied multiplexing, demultiplexing, right? We studied we studied this multiplexing and demultiplexing also. We also studied, after that we studied UDP applications. So we studied about UDP applications. Where actually do we use this UDP, right? And at last we concluded the topic by studying UDP packages. What is UDP packages? So in this module you just learned like how actually this UDP manages or handles the um, the sending and receiving of the packets. Okay.